couple of months ago, a company called GoKWh contacted me and asked me if I'd be willing to test one of their 100 amp hour batteries. Now, I'd never heard of GoKWh before, but they tell me they've been in business for 10 years. If you look at their website, you'll see that they've been making power walls and large capacity power systems, 10 kilowatts and larger. And they decided in the last 3 years to also get into the battery business, where they sell 100 amp hour and 200 amp hour batteries, both at 12 volts and 24 volts. And on some of the batteries, they offer LCD displays as well as Bluetooth. Now, the particular battery they asked me to look at is this 100 amp hour battery, which has both Bluetooth and an LCD display, and it uses pouch cells. You may not know what pouch cells are. We'll talk about those later. A number of companies are starting to introduce lithium iron phosphate batteries with pouch cells as well. In this video, I'm going to do a capacity test. I'm also going to measure the voltage as a function of depth of discharge to see how well the voltage stays above 12 volts. Then I'm going to do a teardown of the battery to check how well it is built and the quality of the components used inside. Plus, I'm going to also check how accurate the display is for voltage, current, and capacity. Now, since GoKWh sent this battery at no charge to me, that makes this a sponsored video. But other than this battery, I've received no other compensation from GoKWh, and I'm under no obligation to give them a positive review unless that's what I think. Not only that, GoKWh has absolutely no input to what I say in this video, and they won't even be able to see the video until you can see it. So let's get into it and take a look at the battery. As I mentioned before, one of the things that interests me about this battery is that this battery is made with pouch cells. Now, there are 3 basic cell configurations which you can find in lithium iron phosphate batteries similar to this. There's the cylindrical cell, which look very familiar to us because they're a lot like the alkaline batteries we've been using for years. Then there's prismatic cells, which look like a rectangular box. And finally, there are pouch cells, like you see here. While each cell configuration can use the same chemistry, lithium iron phosphate, they have their advantages and disadvantages. Cylindrical cells have high strength because of the cylindrical shape and external metal can. You'll find those in batteries from Battleborn. You'll also find them in a lot of Tesla vehicles. Now, prismatic cells have the advantage that they can pack together more densely, so you need less space to get the same amount of energy as you would putting cylindrical cells in the battery box. And you'll find those in lithium-ion batteries. Recently, Tesla started using prismatic cells in some of their EV cars as well. And then there's the pouch cell. The pouch cells have the advantage that they have a very high energy density, and they can be packed together more densely than the other 2 cell configurations. And you'll see pouch cells in some electric vehicles as well, like those from GM. As I said, each cell type has its own advantages and disadvantages, and they're all safe to use when operated according to the manufacturer's specs. The first thing I'm going to do is fully charge this so I can do a capacity test and a voltage versus capacity curve. Charging current for a 100 amp hour battery is typically rated at no more than 0.5 C. I actually prefer that you charge at 0.2 C, which is 20 amps. I have a 10 amp charger, and so I'm going to use the 10 amp charger. Being that this said it was at about 49% of capacity, if we believe that's accurate, it'll take me about 5 hours to charge it. And if I look at the LCD screen, it's saying that the charging current is 9.7 amps. So that's pretty consistent with the fact that this is supposed to be a 10 amp charger. So let's let it fully charge, and then we can do the discharge test. All right, so I have my load tester here. I'm going to draw 10 amps of current, which is the maximum the load tester can do. It will record the voltage, watt hours, amp hours, and I will manually record that so I can see the voltage versus capacity. I can also look at the reading on the LCD display and compare the two. Right now, with no load, this is reading 13.3 volts, and the meter on the LCD display is reading 13.3 volts with 0 output current. And this also gives you the temperature, 15.3 degrees C, because it is early in the morning when it's cold inside my garage. So let's begin to draw some current here. All right, let's see how this compares. So this is drawing a little over 2 amps, 2.27. It says 2.3, 2.4. So that's not bad agreement. 4.5 amps, 4.56, 9, 9.2, 9.2. All right, let's settle down at 10. Okay, so we're right at 10 amps. This one is toggling between 10.0 and 10.1, and this is reading 10. So let's let it run, and I will record periodically so we see the voltage versus capacity curve. So at this point in the discharge test, the battery's internal meter is saying there's 1% capacity left. The voltage at the output is 12.1 volts, and it's still providing 10.1 amps of current. Once the battery has been fully discharged and the internal BMS has shut down the output, you can see the meter reads 0% capacity. There's 10.3 volts internally, but 0 current flowing. This thing is now fully discharged. I measured 103.75 amp hours, which is not a surprise. It's similar to what other reviewers before me have found with the GoKWh 100 amp hour battery. And in fact, it's very typical of a 100 amp hour battery to get 2, 3, even 4% over the rated 100 amp hour capacity. So I would be surprised if we didn't get that. Now, I also measured the voltage versus depth of discharge of this battery, and you see the curve here. Now, I used the voltage from the LCD display, but I also checked the voltage at the 2 terminals with the digital multimeter. And actually, the multimeter and the LCD display agree quite well over the entire voltage range from 100% capacity down to 0% capacity. So what you see here is the voltage doesn't drop below 12 volts until we get to about 96% depth of discharge. And that's very typical of all of the lithium iron phosphate batteries I've measured. And it's more a testimony to the chemistry itself than the manufacturing of the batteries. Now, I don't normally tear these batteries apart to look inside like some of the other reviewers, but I decided to do that with this battery because I wanted to check out some of the improvements they said they made on this battery after previous reviews pointed out some limitations. And I don't recommend taking these batteries apart because even after you've fully discharged it, there's still a lot of energy left in the system, and there is a danger if you don't know what you're doing. Now, this battery is actually quite easy to take apart. It has 8 screws around the top surface, and then has these little plastic plugs, yellow plugs, that cover the screws, and that was the only hard thing to get out. So with the screws taken out, the top just pops off, and we can get easy access to the inside. In addition to the 8 screws, there's also a gasket in here, and also the lip, overhanging lip, to try to keep any moisture and water out. GoKWh sells a less expensive 100 amp hour battery that has an LCD display, and previous reviewers who tore that down found several issues with that particular battery configuration. The first thing one reviewer found was loose connections at these terminal posts on the inside, and I noticed these are not only nice and tight, but there seems to be some sort of epoxy on both terminals helping to keep this from loosening under vibration. So that's good that they made that improvement. The other complaint about the less expensive model from GoKWh was the use of a very lightweight, low-density packing foam to hold the cells inside the external case. And you can see here this black foam is a high-density foam, and that's a nice improvement as well. And the third thing is the LCD on that particular model is just connected to these 2 terminals, so it's not really measuring the internal capacity and current flow and all that sort of stuff. You see this LCD is 4 wires. that are connected down through the side into the BMS. So as we saw in the capacity test, it's actually reading what's really going on inside the battery in terms of the voltage, the current draw, and the capacity. Now on this model, in addition to this high density foam, they have some sort of adhesive or sealant around the edge so that this thing is packed in there very tightly. It's not going to come loose. I'm going to cut into that so I can pull this out. Now they use a 6-gauge silicone coated wire for the positive terminal, and then they use 2 8-gauge silicone coated wires for the negative terminal. And the BMS is down here on the side. I'll say this, I would say the cells themselves were packed inside the battery case very, very tightly. First of all, this dense foam on the 2 ends and on one side were very, very tight fit. Second, they used this, turns out this is just a white silicone all the way around, holding the foam against the side plastic case. And then there's also a bead, it's a fairly thick bead of the silicone on the bottom to hold it to the base. So it's packed in there very, very tightly. This thing's not going to move, so I'm impressed with how well that was held in position. So here's the BMS, and it's on the side of the cell pack. And it's held in place with this fiber tape. It seems to be reasonably secure. You can move it a little bit, but frankly, this piece of high density foam, which presses on the backside of the case, and the other high density foam on the other sides, this is not going anywhere in my opinion. And then there's the high density foam on the top that matches up with the top of the case. So I think with this high density foam and the tight fit, this thing is not going to move around at all. I wouldn't worry about the packing tape. Now if I look at all the connections, we see that they have this red epoxy on all of the connections, which will help prevent any of the screws from vibrating loose. And then over here we have the 4 leads coming from the display, the LCD display, and to the BMS. And then we have the balance leads here coming out of the BMS. And then this black one here, I'll show you in a minute, is a temperature sensor. And if I look, I'm not going to take the BMS apart. If I look in there, I can see some of the solder. It looks perfectly fine, like they did a nice job. If I peel this back, you can actually see what this BMS is. And this is JBD. It's DP04S007S version 1.6. So we'll look that up and see what the specifications on that are. Obviously it does have Bluetooth, and so here's the connection for the display, a temperature sensor, which we'll look at in a minute, and then the balance leads. Okay, we can take a look at one end of this battery pack, and this tape, this is kind of a heavy-duty duct tape, which I cut back to expose the connections to the cells. So you see here are the 3 connections. They're all solder connections, and then they put some more of that silicone on the outside. I'm not sure what good that does, but the other thing is I'm not going to take this all the way apart to expose the pouch cells, but we do know this is made with pouch cells. Other people have exposed those in previous videos, and GoKWh specifies them as grade A pouch cells. And then you can see the positive connection here and the 2 negative connections here, which go back to the BMS. Now if we pull back the tape on the other end, we see 2 more balance cell connections and then a temperature sensor. And I really don't know whether this is high, low, or both. I'll try to give this a try and see what we can find out. So if we look online for this particular BMS by JBD, we see this page here, and that's the BMS that we have. Apparently it comes in different versions. The version we have is this 4S 100 amp hour 12 volt with the Bluetooth and UART. And I believe the UART just refers to this display, which is also JBD. And you see JBD LCD3 UART communication tool for display of smart BMS system. So I think that's the version we have. And I'm not sure why it says 40 to 80 amps continuous. I would think you could do 100 amps continuous on the battery. So I'm not really sure what that is trying to indicate. And it has 4 packs in there and in series to get the 12.8 volts, typical of a lithium iron phosphate battery. And then it actually has multiple ones in parallel to get the capacity. And then there's the specifications on the charging voltage, working voltage, currents, and so forth. And then here are the functions. So overcharge protection, over discharge protection, charging over current, discharging over current, temperature protection, balance function, capacity calculations, communication, and sleep function. They're not very specific on the temperature protection, so it doesn't tell us whether it's high temperature, low temperature, or both. Now, I noticed a couple of other reviewers, not on this battery, but the cheaper battery from GoKWh. The one tested that temperature sensor with a ice pack and couldn't get it to stop charging, which would indicate that it doesn't really have low temperature cutoff. Another person tested it and used a aerosol can flipped upside down, which actually freezes things, makes it even colder, and got the charging to cut off. So it's not clear whether this will really cut off when you go below freezing or whether you have to go very, very low. Okay, so now let's check whether this is actually a low temperature cutoff. I'm going to use this gel pack, which I know can drop the temperature down below 20 degrees Fahrenheit. And then I'm going to use this LCD display here to indicate what the temperature actually is. So we're at 20 degrees C. Let's turn on the charging. And then let's put this in the gel pack and get it folded over and hold it on there tight. Okay, the temperature is dropping. It's down 6 degrees C according to the display, 1 degree C, minus 1 degree C, so we're below freezing, minus 5, minus 7 degrees C, minus 8.8. That's, it looks like the coldest I can get this, 8.9. Hold that on there. Minus 9, still charging, 9.8 amps. Minus 9 degrees C, still at minus 8.3, minus 7 C now. It's starting to warm up a little bit with my hand on there. So I don't think this is going to cut out. Okay, so let's try one more thing. I'm going to use this spray air duster, turn it upside down. That'll get the thing really cold. And again, we can see what the temperature is. So we're at 20 degrees C here. And we're charging, and let me hit it with this. Minus 30 degrees C, and it did shut down. Let's see where it comes back on. Minus 24, 23, 20, minus 17. So it came back on at about minus 6 degrees C. Let me repeat that just to see if we get the same result. Okay, minus 30, and it shut off. And where does it come back on? Okay, somewhere between around minus 7 degrees C, it turned back on. So minus 7 degrees C is right around 19.4 degrees Fahrenheit. So it doesn't seem to want to shut off until it gets definitely below 20 degrees Fahrenheit, which is probably not a good idea. So I've seen some manufacturers specify you could do charging down to 27, maybe even 25 Fahrenheit, but now you're getting below 20 is getting pretty tight. Let me check now for high temperature cutoff. I'm going to use this hot air gun. I'm going to look at the temperature here, and I have this tape so I don't burn myself. Okay. Temperature is 50 C, 60, 70, and it cut off. So the high temperature cutoff does work. So the temperature specs for this battery are 0 degrees C to 45 degrees C. So you don't want to charge below 0 degrees C, and you don't want to charge or discharge above 45 degrees C. So what I found was, I think the low temperature cutoff temperature is set a little bit too low. It looks like it's somewhere around -7 degrees C, which is about 19 degrees Fahrenheit. Either that or it takes a lot longer than a couple of minutes for the BMS to react and shut down. On the high temperature side, it was a little difficult with the heat gun to control the temperature, and it is possible that it actually cut out at about 45 degrees C. Again, there seems to be a little bit of a time delay. So I think, at least on the low temperature side, where I was able to control the temperature very well, I think they have the cutoff set either a little too low or the delay for cutoff a little bit long. And so you can see why, if you saw in the other reviewers, the one that used the gel pack and the one that used the aerosol can, you can see why they got different results. Now, the other thing that piqued my interest about this particular battery, especially in this price range, is the fact that it does have the Bluetooth, which we've discussed before. And you can download their app by simply scanning the barcode that comes on the side of the battery, and you get the app. So here's the app. It shows that I have a state of charge of 2%, and the remaining capacity here, 2.15 amp hours. It shows the total voltage, 12.17, and the display reads 12.2, since it doesn't have another significant figure. The current is 0. The power is 0. We're not charging or discharging. It's showing the high and low voltage of the cells and the difference of the cells. So 3.05, 3.04, and 0.01 voltage difference. And then the average. It's also telling you the temperature. And then you can see the individual cells, 3.05, 0.05, 0.04, 0.04. So let's turn this thing on and do some charging. And we know this thing will charge at 10 amps. So now you see that it's charging, and the charging current 9.83 amps and 120.4 watts. So this is very convenient. You can check on your cell phone what the current state of charge is and an estimate of how much time you have remaining for. So the estimated charge time is saying 9 hours and 54 minutes, which makes sense at 10 amps. And we're at 2.2 amp hours. So very nice to have when you're out in the field or in your RV and you want to, and your battery's tucked away down below and you want to see what's going on. Just use the app to connect to the Bluetooth. And frankly, I haven't seen a battery of this price range that has both the Bluetooth and the display. So what are my overall impressions of the GoKWh 100 amp hour battery? Well, as you could tell from the teardown portion of this video, I was really impressed with the quality of the build and the care and attention to detail. I think they use high quality components in there. I think they put it together with a lot of thought, and so I was very happy to see that. Now, the other thing is, in the performance test, of course, it exceeded 100 amp hours, but that's what I've come to expect from just about any battery. It should be sized slightly more than the rated capacity. And you saw that the voltage didn't drop below 12 volts until we exhausted 96% of the capacity of the battery. So you can run this for a long time with a 12-volt system. Now, the other nice features of this, the included LCD display. If you're out in the field like me as an amateur astronomer and you're wondering what is the current draw of your rig, or how much capacity do you have left, so in other words, how much longer can I go before I have to recharge it, the display, as we found in our tests, is very accurate, not only in voltage and current, but also capacity. And even though I didn't check the accuracy of the temperature reading, I suspect that's actually pretty good too. Now, if you're not near the battery, say you have an RV, which I do, and you install this battery in your RV, and it's located in a compartment that's not easy for you to get to, you just pull out your phone, go to the Bluetooth app, and you can find all the same information right there on your phone without having to dig down in and find the battery. And that can be very, very helpful when you're on a trip and you're boondocking and you want to make sure that your battery still has sufficient charge and capacity left. Now, the last thing that was interesting for me about this battery is they use pouch cells. I'm starting to see other batteries out there with pouch cells. For instance, Lithium Time now has their mini battery out there using pouch cells just like this. And I was going to tell the folks at GoKWh that I think they missed an opportunity to build a much smaller form factor battery, because the pouch cells, as you saw, don't take up a lot of space in here. But it turns out they told me they do have a mini battery coming soon, and hopefully they'll let me test one of those as well. Now, the overall price for this is $329, which I don't see any other 100 amp hour battery on the market with Bluetooth and also an LCD display that is anywhere close to that price. Now, you don't actually have to pay that full price. If you use the link that I put down below the video where it says more, and the coupon code, which I'll put down there as well, you will get $20 off on the regular price. The only thing about this battery that I would recommend that they improve or at least clarify is the cutoff temperature for low temperature charging, and also the high temperature cutoff as well. Either they need to make an adjustment to that or make it clear what the cutoff temperature is, how long the BMS will wait before it cuts off charging at either of those two extremes. As always, I hope you've enjoyed this video, and I hope you've learned something from it. If so, please give me the thumbs up, because that helps other people find the video so they can watch it too. And if you're interested in more of my videos, you might consider subscribing to this channel. So thank you for watching.